This is my first ever printer, and this is the first ever thing I've ever printed. It has been 1 year, 7 months since then. It would be hard to count or list the number of things I've learned and done to and with this printer. You can watch some of the glimpses in the other videos I've uploaded, so let's just fast forward to present day. I printed this fan shroud for better cooling, which helped a little, but the 4010 stock blower fan is very inefficient for part cooling. I often had issues with overhangs and even small bridges. I start by removing the current stock Ender 3 V3 SE part cooling. We will have the gold standard 5015 blower fans to replace old 4010 blower. The fans will be on the two sides instead of the single front blower. Next is the Hotend Heatsink fan, which is a 2510 Axial fan. I will unscrew part of the Hotend to make it easier to install the new Hotend. These are the PETG printed ducts for it to lead the air to the nozzle area. For the heatsink, 4010 axial fan, the Hotend with the silicone socks and the nozzle wiper to add later. I've moved the printer from its usual area, the corner, to my glass desk to better access it. Just during recording of this, I have received my delivery, which includes 4 CHD volcano nozzles and 3 regular volcano nozzles. The K1 Max Hotend already comes with a 0.4, but I will be mounting a CHD nozzle to basically double my flow rate in order to get faster prints. The stock Hotend with the stock nozzle can handle around 18 mm cube per second, translating to about 200 mm per second at common 0.2 layer height and 0.42 wall width. For external walls, I have recently been doing 175 mm per second and it's been mostly fine. However, to print at 500 mm per second or so, a much higher flow rate is necessary, which is what I aim here. So let's take this off to the side. So there are basically 4 sockets that has hot glue, one of which I previously removed by fixing a clock that I had a while ago. I try to be a little careful here because if I rip the sockets, I might have to replace the entire board. Tea time. Later I found out that using isopropyl alcohol IPA dissolves that, which helps remove it. Another method I used here was to just use some heat to soften the hot glue, which was even more effective. At least the thermistor came off, and it does say 260 on it, which would be useful info for later use after storage. I had really hard time removing the Grub screw on the back of the heatsink. Playing back the footage now while editing, I can definitely see that at first I was tightening it down instead of loosening it. So since it was the opposite side, I get confused. I wasn't sure at the beginning, but I was just simply doing the wrong thing. Nevertheless, not much harm done. Eventually I was able to remove it. The Allen key did escape threads a few times. When screwing it back, it was fine. I was eventually able to overcome this as well. Yeah, alright, it's coming off. Let me show you. I did strip a tiny bit, but it's still holding fine. I think there's some thermal grease there. So this was actually one of the hardest parts to do. I still have like memories of it. So my guess is the hot glue was inside of the socket, which made it impossible to remove. After all prying, cutting with the X-Acto blade, I was only able to very easily remove it after just using some heat. I damaged the old Hotend heater socket a little bit, but it will live. Now let's install the new K1 Max hot end. Mount the CHD nozzle. I will apply some thermal grease here. I don't know if it is okay to have these touching. The only thing I'm missing is boron nitrate inside this, which I currently don't have. Let's maybe use this guy. Okay, yeah, it's in there. Nice. Yeah, even this is really tight. Okay, so here's the spacer. So it's gonna be this way, but I think I need longer screws. Why is it so annoying? This thing always falls. Yeah, I made this so much harder. Ouch. It is going a bit off. Hopefully it will correct itself. Now let's do those annoying screws once again. Yes, finally. I think this is bent a little. I need to just remove a little bit of plastic there. I did remove some here, but it's not enough. I think that will mess with my CR Touch. Okay, I just need to remove this entirely. Alright, I just sanded up some part. Hopefully it is enough. Alright, it looks not flat, I would say that. So I started by testing these fans and quickly realized they were wired in reverse. After double checking the underside, I confirmed that the black is actually positive and red is negative, which is the exact opposite of how it should be. The axial fan I'm mounting and the stock fan both follow the standard convention where red is positive. So that means I'm going to have to wire these differently to make them work. I've cut the cables to the proper length, leaving the right one a bit longer so everything reaches the headers correctly. The plan is to bridge the connections, red to red, black to black, on one side, but then I'll have to swap them at the junction to account for that reverse polarity. I'll be joining 3 cables together for each lead before they go into the fan port. I really wish I could have just used the stock connectors, but unfortunately none of the sockets fit. I'm forced to replace them with these tiny sockets, which is a bit of a risk given how small they are. Before I committed to the wiring, I had to verify these were actually 24-volt fans. You see, it happens sometimes where people order 24-volt parts, but if you peel back the sticker, there's a 12-volt label hidden underneath. I tested these starting at 6 volts and worked my way up through a buck converter to 15 and 20 volts. They didn't spin at first, and I was worried they were dead on arrival, but it was just that polarity issue. Once I swapped the leads, they ran fine at 24 volts without frying, so we're good to go. Now I just have to solder everything, which is honestly the biggest hurdle right now. The soldering iron I'm using isn't great quality, and I already struggled just getting a simple lead onto my buck converter. Trying to join 3 wires into one while keeping the joint neat is going to be a pain. It needs to be a solid connection, but small enough to fit inside the heat shrink. I really don't want a bulky, ugly mess hanging off the side of the tool head. I want this to look like a professional, normal install. Once the wiring is cleaned up, we'll mount the fan using these M3x20 screws. On the hot end side, I'm still trying to track down some boron nitrate paste that doesn't cost more than the hot end itself. Until then, I'll have to hold off on that. I also noticed the copper wires on the ceramic heater are touching before they even reach the heater block. I'm not entirely sure if it's okay for them to be in contact like that, but it's something that I'll need to keep an eye on as I finish this up. Let's do a quick height test. Visually, it almost looks like the CR Touch is sitting lower than the nozzle, which would be a disaster, but after a closer look and a quick test, it's actually right where it needs to be. The nozzle makes contact while the probe stays safely retracted, which is exactly what we want. I'm gonna back it up now just to make sure I don't accidentally crash the nozzle into the bed. I did run into a bit of a clearance issue though. This wall here was touching the spacer, so I actually modified the 3D model before I printed it because a commenter had pointed out this exact problem. Even with those modifications, the wall was still pushing against the component. My low-tech fix was to apply a bit of a heat to the plastic and manually bend it down with my finger. It worked. There's finally a bit of a gap there now. Before I start, I'm just making sure everything is tightened down and sitting perpendicular. It's hard to get it perfectly 90 degrees. It might be closer to 89, but it looks solid. In the grand scheme of things, a tiny deviation in the angle shouldn't matter much as long as the probe is at the correct height relative to the nozzle. This should work just fine. With that sorted, I've tidied up the desk and got my soldering station ready to go. Alright, here we go. I'm gonna try and get the red wire soldered first, then the black. If I can get these joined successfully, I can finally move on to the next step. Actually, that looks surprisingly good. I'm almost impressed with myself. For a second there, I thought maybe my soldering iron isn't quite as bad as I thought, but no, it's still definitely a struggle. Let's see if I can get the second one to behave. This is the part where you really wish you had a third or fourth arm. The wire just wants to spring away every time I get close, which is so annoying. Okay, I think I finally got it. I'll just hold it steady for a moment to let it set. It could be cleaner, but I'm not gonna push my luck by messing with it any further. It's definitely good enough for what we need here. Since I obviously can't have these leads touching, I'll use some tape to keep everything isolated. Now let's get this mounted. It feels very solid, even though I'm only using 3 screws because I'm fresh out of M3x20s. I'll eventually add a 4th or maybe replace these, but for now, it's very firm and it ain't going nowhere. Finally, I had to finish the rest of the soldering. This was the most delicate work I've done so far. I'm honestly a little bummed that I wasn't able to record the marvel of patience it took to get this right, but you can see the result. Everything looks like it's making a solid connection, so let's get it all mounted and see what happens. I've done a few more manual adjustments here. I needed to widen the mounting hole slightly and use some glue for the weak parts. The front screw hole lined up perfectly, but the back one was a bit of an issue. Before I mount this, I should give this area a quick sand to clean up that darkening. I'll apply some hot glue to the connections to help dampen any vibrations. Honestly, I never fully trust hot glue for adhesion, but it should help prevent it getting loose. It seems to be holding up well after a quick tuck test, so we'll move on. I've gone pretty heavy with the zip ties to keep the wiring harness safe and out of the way. I'll just cut off the excess here a little bit so it looks better, even though most of this will be tucked away where you can see it. This whole process has been a bit of a time sink, but I'm hoping the final result is worth the effort. The trickiest part right now is the cable routing. If I tuck them one way, they're dangerously close to the hot end. If I move them to the other way, they start interfering with the rollers. I'm trying to find the sweet spot where wires are secure and don't look messy from the front. At the same time, I need to make sure nothing is hanging down lower than the nozzle itself. I finally found a better home for this component. I decided to move it from its original spot because having it tucked behind the heatsink was gonna be a maintenance nightmare. To remove it, I would have had to disconnect the heater cable every single time, which just isn't practical. This new placement is much better. It stays out of the way of the moving parts, even if the cable is a bit longer than I actually need for this area. Time for the M4 screws. Honestly, it's nice to finally have something go right. I had a brief moment of panic. I'd forgotten to secure the duct, but it's actually solid. I'm just gonna be gentle here and not over torque anything. This next screw is being a bit stubborn, but there we go. Everything looks clear. Well, except for one small problem. Right here, you can see the assembly is actually touching the aluminum extrusion. That's definitely going to cause issues with travel, so I need to shift this towards the inside. I'll have to dismantle this section briefly to adjust it. I know some people have run into some issues and ended up stripping it down to a single fan setup to save space, but I'm pretty convinced I can easily have the dual fans work just fine. I'm trying to see if I can route the cable from a different angle. I'll pull one more screw to test the clearance. The cable length is definitely working against me here. It's just a bit too much wire for such a tight space. Ideally, you want a one and done install where you only have to remove the specific part you're working on. Hopefully, this shouldn't be too far off from that. The cable is still catching and rubbing a little. I need to get this to sit flush because the last thing I want is for the frame to eventually cheese wire through the insulation and rip the cable. I think it might be safer tucked underneath if I routed something like this and use a zip tie to keep it under tension. That should do the trick. I'll mount it this way for now and worry about the fine tuning later. Looking at it now, it still looks like it's rubbing. There's actually a tiny gap here. It creates a bit of a bulge in the wiring, which isn't the prettiest thing in the world, but as long as it's not making any contact with the frame, I'm happy. Let's call that done and move on. Moving on to the heater block, there was some leftover silicone stuck inside the heating element. That was a real pain to remove. After melting a bit of it away, it's finally clear and seated properly. I'm not gonna mess with the upper section for now. Getting this part in is a win. To keep the fan secure against vibration, I'm adding a bit more silicone. Honestly, I find this manual application works better than a glue gun for this specific setup. Hopefully, it's all safe and secure. Now, for the CR Touch. I need to be careful here to route the cable behind the assembly so it doesn't snag. It's a tight fit, but it barely clears. Now, for these screws, the ones I managed to drop every single time. I swear, I'm not doing this on purpose for the camera. It just happens. I know I can't convince you otherwise, but that's the truth. If I can stop fumbling with the hardware, we might actually be done with this in under 30 minutes. Looking at other K1 hot end replacements on this printer, the cable management usually looks pretty rough. It might seem like I'm doing a lot of extra work here, but I've just been dealing with some bad luck during the install. I'm really curious to see the performance gains. I've got notes on everything: cooldown times, heat up times, and especially the flow rate. The stock hot end hits about 18 millimeters cubed per second, so I'm looking for a big jump. I did have to undo the back assembly again. This is what I mean by unfortunate things. If I had the perfect screw lengths, it would be easier, but the designer used nuts on the back of the print instead of heatset inserts. Putting a nut on the back adds thickness and makes the whole thing a bit clunky to put together. It's not the most elegant solution, so I'm hoping I won't have to do that. The screws stick out a tiny bit, but on the head side, not on the back. But the overall look is pretty decent. The tool head is significantly larger now. Let's do a safety check to make sure the nozzle is the first thing that hits the bed. I know the CR Touch clears, but these fans are sitting very close to the build plate. It's hard to show on camera, but it's a tight squeeze. I might need to take a file to the edges later if there's any rubbing. But for now, let's get the silicone sock on. I already installed the Grub screw off camera. For the sock, I went with the black one and had to trim it down to make sure the CHT nozzle sticks out because it's a bit shorter than the nozzle that came with the hot end. The whole assembly is very packed now. I didn't get a chance to weigh the new parts versus the old ones, but I really dig the new aesthetics. I also have these heat sinks to mount. I have thermal pads, but I'm not sure if there's adhesive behind it to hold it at all. To my surprise, they're actually quite tacky. They seem to hold their own weight just fine, so I'll trim them down to size, take out very easily, and get them mounted. That was a little nice win I wasn't expecting. This is the printer's temporary home, but I'll be moving it back to my sturdier drawer cabinet right after this. I've got an LED bar ready to go, though I haven't wired the actual LEDs yet. I also picked up a basic filament runout sensor. It's not the official Creality version, but it'll do the job just fine. The wiring colors are mismatched, which is weird, but I'll figure that out and route these cables through the same spot as the LEDs into the motherboard later. The next big step is installing linear rails on the X and Y axes. You can see linear rods used on some Core XY printers, so the Y-axis rods should be fine on paper, but they're quite noisy, and I think the linear rails will allow for much higher acceleration, which is what I aim here. I'm gonna be trying to max this printer out in terms of speed until I eventually am able to convert it to a Core XY, which is what brings us to my ultimate dream, to make this into a DIY Core XY machine. There's not a kit for that, so it will be a totally custom job, but as long as I can find the parts I want, I think it's doable. For now, let's plug it in and see if it actually runs. If everything checks out, we'll see what kind of flow rate and speed we can actually pull. If we can get from that stock 18 millimeters cubed per second up to 50 millimeters cubed per second, I'll be thrilled. If you enjoyed the build, like and subscribe. I'll see you in the next one. This is being printed at 0.2 layer height, yet it's almost impossible to see the layer lines. I'm really impressed with the quality. I will perhaps continue with the nozzle wiper, LED bar, linear rails. Maybe, hopefully I will be able to squeeze in the enclosure in the next part, and then we'll see what we can do with this little machine. I will need to stabilize the printer drawer cabinet surface a little bit. This was sitting parallel to the wall you see, which was a little more stable, but for convenience and for use of enclosure, I had to turn this 90 degrees, which is much more convenient to access. But now it shakes a little bit more. So while working with the enclosure, I will have to also fix that. Maybe I will secure the drawer cabinet to the wall, something like that. The cabinet surface isn't even fully level, so there's a lot to improve, and I believe this can get even better.